The problem: researchers in agronomy and plant sciences face challenges in accurately monitoring plant growth due to manual data collection, which often leads to inconsistent measurements and subjective observations. Lack of real-time monitoring can result in missed critical changes in plant health or growth, especially during environmental fluctuations outside of regular observation periods. These limitations introduce biases and errors that hinder research progress and the quality of insights. Existing greenhouses often lack precise control over environmental factors such as light, irrigation, and temperature, and the foliage obstructs sunlight and creates uneven conditions. The absence of automated systems makes it difficult to maintain stable environments, essential for valid and replicable results. The Smart Greenhouse Project is a miniature version of a prototype designed to create a controlled environment for plant growth by customizing irrigation, temperature, lighting, and ventilation. It consists of a big box with 2 isolated chambers. The system monitors plant growth by calculating leaf count and green area using image processing techniques, such as pre-processing and watershed algorithms, applied to photos taken by a mobile structure. Growth metrics are visualized on a website, and so are environmental parameters like temperature, humidity, and soil moisture, and track water reservoir needs. The greenhouse regulates irrigation with a water motor and sensors for soil moisture and water levels. Temperature is controlled with a sealed structure, Peltier cooling system, heating resistor, and temperature sensor. Lighting is managed with growth lights that support photosynthesis. The project integrates hardware and software to provide parameter adjustments for each chamber through an easy-to-use web interface. So now we are going to show the details of the project. Starting with the website, we can log in and then select a project to get in. The first thing that you will see is the main page, with the option to choose between chambers and the correspondent data of them. As you select them, the correspondent data will be updated. If you have the rights to do it, you can access the control panel to visualize and change the parameters of the selected chambers. Here, we are setting the chamber 1 temperature to be 28 Celsius and the chamber 2 to be 20 Celsius. As you can see, a few seconds after saving the changes, the cooling system of the chamber 2 on the right is activated, and you can see the fans spinning. To achieve the desired temperatures, we will close the structure so the fans on top and on the side can make the air circulate right. After some time, we are seeing the chamber 2 dashboard data. As we can see in the temperature graphic, we cooled down from 25.45 to the 20 degrees Celsius. And in the other hand, on the chamber 1, we managed to heat up from 25.48 to 28 degrees Celsius. Now we're going to see about lighting and photo system. Here we are setting the light schedule of the chamber 1 on the left to be activate on the current time. Also, we are setting both chambers to take pictures on this moment. We can clearly see the camera structure movement. The camera is in the middle of the structure. When the photo is being taken, the LED grow light is shut down temporarily to be able to use the flashlight to assist in the photo capture. After taking the photos, we can go to the photo gallery to check out the results. Here we can see the highlighted area that represents the leaves that are identified. On the metric panel, we can check the number of visible leaves and also the green area estimated. Take in consideration that those photos were taken without the structure being properly covered. And now we are back to the control panel to set light schedule of the chamber 2 to be also activated. Still talking about ventilation, there is a parameter in the Controls tab to program the activation of internal ventilation to renew the internal air. This will cause both lower hatches to open and both coolers to activate. Now, we are going to check the irrigation system. On the metrics page, we have the soil moisture value, which indicates the humidity of the soil. If we set this value on the control panel to be higher than the current level, the water pump will activate until this value is exceeded. As we can see, the pump makes the water flow through the hose and eventually drip into the vase. As we can see here on the left, the value on the website is updated in near real time, as shown on the right. On the metric page, there is an indicator if the water reservoir below 20%. We can see that in the chamber 1, everything seems all right. Now checking on chamber 2, we need to refill the reservoir. After refilling, we can check the update on the website on the right. That's it. Thanks for watching.